Hey everyone, Mr. Newman here, and today we're going to learn about systems of inequalities in word problems. I'm only going to do one problem, so pay very careful attention to the details when I explain each part, and let's get started. You can work at most 22 hours next week. You don't want to earn more than $150, otherwise you'll have to report this week on your taxes. Your dog walking job pays $750 per hour, and your job as a car wash attendant pays $6 per hour. So first thing we need to do is figure out the variables. The things that can change are how much, let me underline these things. Those are important because those are kind of like our totals. 22 hours is the maximum, was one maximum, and 150 is the other maximum because of taxes. So, and one way of thinking of it is at most 150 is you don't want to earn more than 150. Now, if these are our two, you see the per hour, those are kind of like our rates. Those are what are going to be multiplied by our variables. That means our variables must be the number of hours walking the dog and the number of hours working as a car wash attendant. Now, instead of using D and C as our variables, I would recommend using X and Y. The reason for that is because, as you're going to see in a second, linear inequalities always have to be graphed. They always have to be graphed because there's millions or billions, an infinite number of correct solutions. And you can't show all those solutions just by writing a few numbers down. You have to show them in a graph. Now, because we are using X and Y, let's just pick the first one, dog walking, as our X. And notice how it's very specific. I said it's hours of dog walking, not how much you make from dog walking, all right, or cost of dog walking. It's hours spent dog walking. And then the Y is going to be the hours spent washing the car or car washing as a car washing attendant. So those two variables can be at most 22 hours, right? If we add them together, you can't work more than 22 hours. So the way we're going to say that is X plus Y must be less than or equal to 22. Notice that at most includes 22. You could work 22 hours. That's why we need to have the or equal to. But you cannot be more than, so less than or equal to 22. For the other one, we're going to use our rates. So 7.50 times X, that's because you make $7.50 an hour, plus 6 times Y, that's because you make $6 per hour in the car washing. And what those two things are going to do is that's going to give us how much money you're going to make total. Well, you said you cannot make more than $150, otherwise you'll have to report it to your taxes. So, if 150 is the maximum, the most you can make, those two quantities must add up to be less than or equal to 150. So we write less than or equal to 150. Now, for graphing it, because this is not in slope-intercept form, because it doesn't look like y equals mx plus b, the fastest way to graph it is to plug in 0 for x and see what the y value is. And then plug in 0 for y and see what the x value is. So I'm going to do that here in the table. Plug in 0 for x. Well, when x is 0 in that, if we turn that into an equation, 0 plus what equals 22? Well, that's going to be 22. And likewise, if we put in 0 for y, what plus 0 equals 22? Well, x must be 22 also. So that table is pretty fast to fill out, and often one of the tables will be pretty fast to fill out. For our blue equation, though, I want to write this down in this big bubble up here, or this big cloud, so you guys can see what I'm doing. When you plug in 0 for x, we're going to put it right there, and we just need to solve for y. Well, one of the reasons I choose 0 is because that simplifies the equation. 7.5 times 0 is 0, so you can ignore that part of the equation, or you can remove that part. Then we divide by 6 to solve for y, and y equals 25. So in my table, I'm going to write 25. That's going to be 1 point. Then if we plug in 0 for y, that's going to look like this right here. Plug in 0 for y. When you solve for x, you'll divide by 7.5, and you get x equals 20. So x is 20. So you see how we made a table of values just like before, but instead of plugging in random numbers, you plug in 0 for x, find y, and then 0 for y, and find x. That is, in my opinion, the easiest way to find points when you're given standard form inequalities like the ones above. Okay, let's go ahead and rewrite that. So notice what I'm doing now is I'm labeling these points down here, okay? And I chose these points because I saw that my x value, the highest number x value, is 22. And if I went by 2s, I don't think I would quite get there. Likewise, I'm going to go by 3s on the left side, just so that I cover up to 25, because 25 is my biggest y value. Now, for the red one, let's plot these points. Oh, last thing we need to do is we need to write down what our x and our y mean. So x was hours spent dog walking, and y was hours spent car washing. Okay, and I'm going to plot these 2 points here. Whoops. So a few things first off. Notice that one point is 20, 0, or sorry, 0, 22, and the other point is 22, 0. And the other thing I need to do is, you notice up there I'm writing down, this is going to be a solid line because of the less than or equal to sign. So let's draw a solid line, and we need to test 1 point. So I'll test 0, 0. Well, 0 plus 0 is 0, so 0 is less than or equal to 22, so it's true. So we need to shade the bottom left side. So I'm going to shade it in like that. All right. Then let's plot the the blue points. You notice I plotted 0, 25 and 20, 0. Those 2 points are plotted there. This is also a solid line because it's less than or equal to. And so I've got a line there. All right. Now, we're going to test 0, 0 to see which side of the line we should shade, above and to the right of the blue line or down and to the left. Let's test 0, 0. So I plug in 0 there, and 0 there makes 0 on the left side. So 0 is less than or equal to 450, and so that is also true. So let's shade in the bottom left side, the side that includes 0, 0. I did not label 0. I probably should here. Let's label 0, 0. That's a 0, 0 right there. That's why I'm shading in the bottom left side. So, which area is shaded in by both the blue and the red? Well, it's this area down here. So it's the bottom left section, not including that little blue section and not including that little red section in there, okay? Just the part that is down here. So the last thing we need to do is it says state 2 solutions to the system you wrote. All we need to do is find 2 points inside of that shaded area. And it's a good idea to find points close to the lines to show we're kind of maximizing this, because ideally, like in this situation, you want to make more money. So the more money we make, the better. So let's do this. 2 solutions. One, I'm going to pick a point right there, just a point on the line. That's 9, 12. And we need to write down what that means. Well, that means that 9 is the x value. That's hours dog walking. So it's 9 hours dog walking, and it's 12 hours washing the cars. That is what that point represents. That means that if you spent 9 hours dog walking and 12 hours washing, you would be under your 22-hour limit, and you would make less than $150, which was your goal. Right here is another point. I'm just going to pick a point on the line to show you one of the extremes. We could not go any more to the right because then we'd be out of the blue area, and we have to be inside both the blue and the red. But that point, 20, 0, that fits the under 22-hour rule and the under $150 rule. And that's 20 hours dog walking and 0 hours washing. That is another possible solution. But you could pick any of these points in here and still be acceptable. All right. Thank you very much for watching.